says these are the same polynomial. So the top one we call standard form. How many terms is it? 4. 4. Remember all that we did earlier this year? What's the degree? That's the largest exponent would be what? 3 is the degree. Okay? What is the leading coefficient?
1.
It's a 1. It's hiding in front. It's the number that's in front of the largest exponent. And then what's the constant? 12. All of that's standard form, right?
Yeah.
This is what we've been working with more recently. It's something called factored form. What is factored form good for? Finding the x-intercepts, right? Basically what happens if you set each of these equal to 0. So for example, let's say I take x plus 2 and I set it equal to 0. What is my answer for x? Yeah, subtract 2 over, and we get x equals negative 2. We call that an x-intercept. Sometimes it's called a 0 because it's on the x-axis, which means y is what? 0. Yeah. So what would this x-intercept be? 2. And what would this x-intercept be? 3. Okay. So based on this information, standard form, what is this number always going to be? It's always the y-intercept. Y. If you plug in x is 0. Yeah, if you plug in x is 0, what happens to, what's 0 cubed?
0.
What's 3 times 0?
0.
What's 4 times 0?
0.
All of those cancel out and you're left with 12. So the y-intercept is always the last number in standard form. Okay. What does factored form tell us again? The x-intercepts. What's the degree? Which form should I look at for degree? Remember, degree is the largest exponent. Yes, standard form. So what is the degree? It's 3. Now, if I did not have this, how could I figure out the degree? Yeah, you basically count up the x's. Because if I were to FOIL all this out, what's x times x times x? X cubed. Yeah, so you still see the 3 there. It was hiding, okay? What is the end behavior going to do? So if I had a little sketch here of my x and y axis, where do I look? There's a lot of stuff on the screen. Where do I look to figure out where the polynomial starts and ends? You look at the first term in standard form. And this is a positive, and 3 is odd. So it starts at the bottom of the mountain, and it ends at the top of the mountain. Remember that? What if there was a negative in front? What's it going to do? It's going to go down the mountain, start at the top and end at the bottom. What if it's an even exponent? Or if it's negative, it would be down, down. Okay? So we're starting to put all of these things together. What do you think would happen if I typed this in Desmos and then I typed this in Desmos? It's the same thing. So if we look at this real quick, you don't have to do it. I'm just going to type it in on my Desmos. We can see those different features kind of happening. So y equals x cubed So here's both forms. See the red one? See the blue one? Red, blue, red, blue. Now let's focus on the red one. What's the y-intercept? What did we know the y-intercept was? It's 12. See it right there? So if I go up, where does it cross the y-axis? Right there at 12. Okay? What did we say the end behavior was? It's a positive odd polynomial. So where should it start and where should it end? Starts at the bottom, so see how it starts at the bottom? Does a little curlicue, and then it ends at the top. It keeps going up and up forever, okay? What are my x-intercepts? What did we know those were going to be? What is this one? -2, +2, +3. So if I go down here to the x-axis, -2, +2, and +3. All those x-intercepts are right there, okay? All right, so now we just have to put everything we've learned together. This is like the last thing to do for the whole learning target. So everyone go back into your notes now and find this example 7. Okay, first, and I put the steps up. Does everyone find it? Example 7. Yep, perfect. Example 7. First thing we should always do is determine the end behavior. So look at the first term. This is a +2 and an odd degree. It's a positive odd function. So what are the arrows going to do? Up, up, down, 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 up, down. Good. It's going to start at the bottom and it's going to end at the top. So go ahead and make those notes on your graph so you'll remember that. All odd functions have the same end behavior. So it's just like a line. If a line starts at the bottom, it has to end at the top. Okay, the next thing that I can really easily figure out in this form is what? You're going to see it's the same as quadratics because quadratics are polynomials. On the snapshot we just took, if it's in standard form, the y-intercept is the last number. So down here at -12, it's a little bit off the graph, but still graphable. That's something else we always know. The last number in standard form is y-intercept. Do what? What? Did you ask why? Why is that, though? How do you find the y-intercept? Yep, so those all cancel with -12. Okay, next step. Step 3 says step 2. Factor and find the zeros. So in order for it to be in factored form, we have to factor it. So this is going to be a good review because we haven't factored 4 terms in a while. Remember your flow chart is the last test. How do we factor something with 4 terms?
Grouping.
Yeah, GCF's always first, but is there a GCF of all 4 terms? No, 2 doesn't divide by 3, 3 doesn't divide by 2, the last term doesn't have an x, so there's no GCF. So who said it? Someone just said it. Grouping. Okay, so ignore the second half. This is a really good review for some of you. What's the GCF of the first half only? What do both of those terms have in common? They both have an x squared. Now if you take x squared away from them, what's left? 2x plus 3. Did everyone see what I just did? I just brought out the GCF. So you can see if I distributed this back through, I'd end up with 2x cubed plus 3x squared. Okay, now the second part of grouping, you ignore, I'll do a different color, you ignore the first half. What's the GCF of the second half now? -4. So I'm going to bring out a -4. And we now have to divide both of those terms by -4. So what's left? 2x. A negative divided by negative leaves a positive. In other words, we're taking the negative away, so it's positive now, right? Now, if you remember, if you do it right, these should match. Do you remember that?
Yeah.
What happens to those 2 matching parentheses? They what? Yeah, good. Those get factored out front because they're the same. So 2x plus 3 comes out front. And it really doesn't matter if it comes out front or goes behind. I just think of it as pulling it out front. Now, if I take those out front, what's left behind? X squared minus 4. Now you guys are masters at factoring now. You should know that this isn't done. This is not done being factored. Why? Because there's an x squared. It's a difference. There's a minus sign. And what do we notice about the two things on each side of the minus sign? They're squares. They're perfect squares. So the 2x plus 3 is done with. We're done with the 2x plus 3. But this one breaks apart into 1 plus, 1 minus. You remember that? Plus you. And then x times x is x squared. And then what times what is 4? 2. Now we're done. So you have to be able to factor. That's why that test was so important. Now that it's factored, we can find the x-intercepts. So the way we find the x-intercepts, you set the whole thing equal to 0. Now let me ask you this. What is 2 times 0 times 3? 0. What's 0 times 2 times 3? 0. What's 2 times 3 times 0? If you're multiplying things together, how many zeros does it take to wipe everything out? Only 1. So even if this one's a 2 and this one's a 3, if the first one's a 0, what's our answer? 0. So keeping that in mind, how many factors do I have here?
3.
3. There's 3 factors. Something times something times something. If I'm trying to solve it to figure out when it equals 0, well, technically any of them could equal 0. This one could equal 0, this one could equal 0, or this one could equal 0. So what you have to do is you have to set each one equal to 0 and find that solution that causes the whole polynomial to be 0, which we know are the x-intercepts. Right? If we're at 0, that's the x-axis. So if I set this equal to 0, now most of you can probably do that in your head. What are you going to get as an answer? Positive 2. That's what you just did on your snapshot, right? If I set this equal to 0, what's my answer? So like x plus 2 equals 0. Just like algebra 1. Subtract the 2 over, and it's the opposite. That's why we do that. It's negative 2. It's a negative. And then the last one, this one's maybe not quite as obvious. What x-intercept do I get out of that? It's not 3. It's not negative 3. If you set 2x plus 3 equal to 0, and set that factor equal to 0, you'd have to subtract 3 over. And then you'd have to divide by 2, right? So therefore, x equals negative 3 halves. What's that decimal? Negative 1.5. So throw those on your x-axis. 2, negative 2, and negative 1.5. 2, negative 2, and negative 1.5. I know those are close together. Now the last thing to figure out, do any of them bounce? When I got down here to the very end, were any of these squared? Were any of the factors squared? No. So none of them bounce. We're going to start at the bottom of our mountain. Here we go. We're going to go up. We're going to cross through. We're going to cross through. Go down and hit your y-intercept. Might as well. And then cross through and look. It ends up like we knew it would. So last one, we're going to do the whole thing. This is a positive even function. So what does that tell me about the arrows, my end behavior? Up, up. It's going to start up, and it's going to end up. What's my y-intercept? You should know it like that. It's -6. The last number when it's in standard form. Those are the two things that standard form tells you. The arrows and the y-intercept. For everything else, we need it to be factored. Okay? So now we have to factor it. What's the first step of factoring always? You guys said it earlier. GCF. What do 6 and 6 both divide by?
3.
Oh my. 3, yeah. But the largest would be 6, which leaves behind x to the 4th minus 1. Write that down. We with me so far?
Yes.
Divide out the 6 is all we did. Now, x to the 4th minus 1 is a difference of two perfect squares. So, we go 6. This breaks apart into 2. One's plus, one's minus. How many of you still have your flow chart? Bless you.
Wait.
You don't need to get it out right now, but that's something that'll be really helpful to you. You still have to know how to factor. Remember, it looks like this.
Oh, yeah.
So if you have that, I would maybe locate it soon. Okay, so what times what is x to the 4th? X squared. And what times what is 1? 1 times 1. Okay, 6 out front. This is called a sum of squares. Do you guys remember how a sum of squares factors? It's imaginary. So it's just like the difference of squares. One's plus, one's minus. X times x is x squared. What times what is 1? 1 times 1.
1 I.
But you have to put an I. If it's a sum of squares, if there's a plus sign in the middle, that's the one that breaks apart into imaginary factors. And now the last one, I'll do it in blue. What is this again? The difference of squares, which is just our normal x plus 1, x minus 1. So how many factors do we have?
5.
4 main ones with a GCF. But does the GCF have an x in it? No. So if I take 6 and I set it equal to 0, do I get anything out of that? No, there has to be an x to get an intercept. So now I'm going to work kind of backwards. If I set this equal to 0, what's my answer? X equals 1. So that's on the x-axis at 1. If I set x plus 1 equal to 0 and solve for the 0, what do I get? Minus 1. So that's on the x-axis at -1. Imaginary means there's no x-intercepts. If it's imaginary, that's telling you that that factor does not give you an x-intercept. So how many actual x-intercepts do we have? 2. And we're done. Do any of them bounce? Were any of them squared? Nope. When we got down to our final answer, we had 1 of each factor. So the 2 that actually gave us x-intercepts, especially, neither of those are squared. So we're going to come down. I'm just going to move these because those are kind of out of place. But it's going to come down. It's going to hit the y-intercept, and it's going to end up. It kind of looks like a parabola. There's not a lot of squiggly stuff happening with this one. It's an x to the 4th power. Everyone graph it in your y equals scope. So go to y equals and double check your work. 6x to the 4th minus 6. So y equals 6x to the 4th minus 6. Which was similar to a parabola, right? Now it's not a quadratic, it's an x to the 4th power, but you can see they're pretty similar. Can everyone see the x-intercepts of 1 and -1? Did it cross the y-axis at -6? Yep. Did it start up and did it end up? Yep, all those things we knew were going to happen happened.